Good day to you. I'm Sanjula and I will be presenting about the paper on accuracy of the commonly used pile integrity testing methods in Sri Lanka. Other authors of this paper are Professor H.S. Thilakasiri and Engineer R.M. Abeysinghe. This presentation consists of introduction, problem statement, methodology adapted, analysis of the test results, discussion of the results and conclusions of it. Moving on to the introduction, in Sri Lanka, the use of pile foundations has increased with the rapid construction of high-rise buildings, which requires very high bearing capacities. But the construction difficulties and improper quality control measures undertaken can result defects along the pile shaft, which reduces its load-bearing capacity. So it is important to recognize the integrity of these piles before construction of the superstructure. And among various testing methods available for integrity testing, the pile integrity test, the pile driving analyzer, cross-hole sonic logging test, and coring of the pile can be considered as the most commonly used methods in Sri Lanka. Moving on, I would like to briefly introduce each and every testing methods discussed in this research. When considering the pile integrity test, it is an undestructive surface reflection small strain test method, which requires impacting of the pile center using a small handheld hammer to measure the particle velocity along the pile shaft. Here, the number of velocity records are taken, and after that, by investigation of the obtained velocity records, the defective areas of the piles could be evaluated. The pile driving analyzer is an undestructive high-strain testing method where a dynamic impact is applied to the pile top through a large hammer blow. So here the acceleration and the strain of the pile top is measured in order to identify the defects in the pile shaft. In pile driving analyzer, two approaches are used to analyze the obtained data, which are the case method and the CAPWAP method. When looking at cross-hole sonic logging test, it is an undestructive direct transmission test where an ultrasonic pulse is sent through the pile shaft using a transmitter and a receiver. These are lowered through pre-installed access tubes. Here, the first arrival time and the energy of the pulse is measured to identify the defects. The tomography analysis is the three-dimensional analysis of cross-hole sonic logging test results, and this provides more visualization of the extent and the depth of the defect. Pile coring is a destructive method of testing which was widely used to check the pile integrity, and here a hole is drilled through the pile to visually observe the defects. But this method should be executed very carefully since even a small tilting of the drilled hole could provide incorrect interpretations. Moving on to the problem statement. In Sri Lanka, the common practice is to conduct different testing methods to the same pile profile when obtained integrity of the pile is not satisfactory. But when comparing the output results, they might subjected to variations in different situations. So it is necessary to identify the causes for these variations to interpret the accuracy of the test results. The methodology adapted in this research consists of first key information collection and background study, followed by field data collection. Then the collected data was sorted and arranged so that the variations in the test results could be identified through comparison of data. After that, the study was concluded with result interpretation. Moving on to the test results analysis. A pile sample consisting of 30 piles were analyzed in this research, and first they were categorized into two main categories. So the category A is piles with confirmed defects and category B is piles with semi-verified defects. So here for category A, piles with coring data were considered, as coring provides confirmation of the defects present in the pile shaft. The table 1 represents a percentage of piles considered for each category and combination. But due to lack of available coring data, the percentage of piles considered for category A is considerably low, which could be identified as a limitation of this research. As an example, first we'll consider a pile of category B combination 3. The table 2 represents summary of CSL results for each 6 profiles. So from that, it is clear that around 2.5 meter depth, the pile has 1 poor flow, 2 poor defects, and 2 questionable profiles. And also around 15 meter depth, 2 questionable profiles have been identified. And correspondingly, as in figure 11, the tomography analysis results have indicated the 31% defective zone around the 2.5 meter depth. So when considering these tomography and CSL results, this file indicates a considerable defect through the CSL data. So moving on to the PIT test results of the same pile profile, the velocity recorded in the figure 12 has not indicated any positive reflections. So the PIT test results indicated the perfectly sound pile, which is contradictory to the corresponding CSL results, which I explained in the earlier slide. Also, it could be observed that in figure 12, there's no clear toe response indicated, which could be due to improper propagation of the stress wave to the toe area. And this could be considered as a possible cause for variation. So as in the example, test results of the selected 30 piles were analyzed and compared to identify the variations in the output results. And moving on to the discussion, when considering the data obtained, it could be observed that majority of the piles have defects around the pile toe region, which implies that the pile toe construction is critical. And in combination 1, the piles subjected to both coring and CSL have indicated similar results, which proves the accuracy of CSL by confirmation of the defects by coring. And in regard to piles in combination 2, where coring and PIT is considered, it has provided different outcomes of pile integrity, and this questions the ability of PIT to accurately identify the defects in the pile. And as shown in figure 13, 58% of the piles in combination 3 has indicated different interpretations in PIT and CSL data. And from this 58%, 57% of the piles, that is the majority, has not indicated the clear toe response. So this may be due to improper propagation of the stress wave to the pile toe area. And if we consider CSL and PDA results in piles of combination 4, only 27% of the piles have shown different results to CSL data in both case and the CAPAC methods, as shown in figure 50. And also, it is clear that 73% of the piles has indicated similar results to CSL by either case method, CAPAC method, or by both of the methods. Moving on to the conclusions, it is clear that the CSL along with tomography analysis has indicated accurate results on the pile integrity. So, and this is concluded since the results have been confirmed by the coring data. And also PDA has shown considerable accuracy than the PIT when compared with CSL. And majority of the piles which have shown opposite results to CSL has not indicated the clear toe response, which could be the reasons for the variations in the test results. And when considering the PDA data, the CATPAT method has shown high accuracy levels than the case method. And also it is apparent that a better understanding of the depth and the extent of the defects in the piles could be obtained by proper utilization of combination of testing methods rather than conducting only one test. So these are the conclusions derived through this research. And that is the end of the presentation. Thank you.